Greetings, welcome to this session on replacement of small items, which we will also call as group replacement. This is the fourth video in the series of replacement models. We had three videos already on replacement of capital items that consider time value of money and without time value of money also. And in this video, we're going to have a look at replacement of small items which are not too expensive individually, but it makes sense to buy them and replace them in bulk. Something like our bulbs, the light bulbs that we use for domestic purposes, or the resistors and small items which could cost a rupee or two. Now, if we were to look at this definition of group replacement, you can see this here on the screen. Group replacement is concerned with items that fail suddenly, and these are small items. And it's more economical to buy them in bulk and replace, taking the quantity discount factor into play, rather than buying one item at a time. So let's have a quick look at one illustration here. You can have a look at this question, as I always suggest. Take a screen snapshot of this question, copy it down on your notebooks. It'll help you to solve it. Okay, having a look at this question, let's see what it means. There are about 1000 bulbs, and we have a table which says in about 5 weeks, all of them fail. And this says it's percentage of failure, which means in the first week, 10% of the bulb fail rather. And in the second week, it's a cumulative of 25%, which means in the second week alone, it is only 15% failure. Here it shows that it is 25% cumulatively, 10% in the first week, 15% in the second week, both put together, it is 25%. Now, how do I know whether this is a cumulative percentage or it's an individual percentage? If the final week has 100, that means it's cumulative percentages that have been given. But in some problems, it's quite possible that you'll have the percentage of failure per week, in which case the final week's value may not be 100, but the cumulative should work out to be 100. Now looking at this, let's explain this. It's 10% failure in the first week, 15% failure in the second week, 25% failure in the third week. How did I get this 25%? That is 50 minus 25. Till the second week, 25% has failed. In the third week, 25% has failed. So put together it is 50%. In the fourth week, 30% failed. And in the fifth week, 20% of the bulbs fail. So in all, none of the bulbs survive beyond 5 weeks. That's the data that we have here. There are totally 1000 bulbs. And if I keep replacing one bulb at a time, or the number of bulbs as they fail at a time, then it costs me rupees 2 to replace bulbs as and when they fail. But if I were to buy them in bulk, let's say I use quantity discount and I buy all 1000 bulbs together, then I get it at a price of 50 pice per bulb. If it's individual purchase, it's 2 rupees per bulb. So the question is, do I follow group replacement, or do I replace the bulbs as and when they fail? Now we will try both options and see which is more economical of the two. Now, as I had said earlier, looking at this data, we know 10% of the bulb fail in the first week, 15% in the second week, 25% in the third week, 30% in the fourth week, and 20% in the fifth week. Now that's what we have here. The first two rows are as we had in the data itself. The third row is in terms of the probability, which adds up to 1 here. And the fourth row is the individual probability of failure per week. So 10%, 15%, 25%, 30%, and 20%. Now first we will check out what is the cost if I were to replace the bulb individually as and when they fail. Now for that what we do is we first find out the average lifespan of the bulb. Then we find out the average number of bulbs that fail per week. Then we find the cost of replacing the bulbs each week. So in order to get the average lifespan of the bulbs, we use this relationship sigma I into pi. This is a discrete summation relationship. I is the number of weeks, so it's 1 to 5 here because we have 5 weeks in this problem. Pi is the probability of failure in that respective week. So it's 0.1, 0.15, 0.25, 0.3, and 0.2. So that's what we have here. First week into 0.1, the probability of failure of the first week. Week number 2 into probability of failure of week number 2. Week number 3, probability of failure of week number 3. Week number 4 and probability of failure of week number 4. Week number 5 and probability of failure of week number 5. All this put together, we get about 3.35 weeks is the average lifespan of the bulbs. Then we look at the average number of bulbs that fail. So it's 1000 bulbs divided by 3.35. We get 299 bulbs that fail every week. Now if I were to replace the bulbs as and when they fail, it costs me 2 rupees per bulb. So I would be spending about 299 into 2, 598 rupees per week if I were to replace the bulbs as and when they fail. Now remember this cost, I'm going to spend about 598 rupees per week if I were to replace the bulbs as and when they fail. Now let me consider this possibility of replacing the bulbs in groups or in bulk, all 1000 bulbs at the same time. How much does it cost me that way? Now have a look at this. N naught is the number of bulbs I replace at the beginning of the first week. N naught means the number of bulbs at the beginning of the first week. N1 is the number of bulbs at the end of the first week. N2 is the number of bulbs at the end of the second week. So N naught alone is the number of bulbs at the beginning of the first week. That's, let's say, 0th week. So I replace all 1000 bulbs, presuming there are no bulbs in the holder. So beginning of the first week, I am replacing 1000 bulbs. At the end of the first week, 10% of the bulbs have failed. So N naught, which is 1000, multiplied by 10% of that, so 1000 into 10% of that, 100 bulbs fail in the first week, at the end of the first week. Likewise, in the second week, at the end of the second week, N1, 100 bulbs that I've replaced, for that set of bulbs, it's the first week probability, so P1. For the original set of 1000 bulbs that were replaced, it's the second week probability P2 because it's the end of the second week. So it's 100 into 0.1 plus 1000 into 0.15, which is the probability of the second week. Now it's quite possible that you might wonder why is it an N naught here and not N naught minus N1 into P2, because N naught is 1000, which we had replaced in the beginning of the first week. But for N1 number of bulbs, it is only 1 week. So probability of P2 for that set of 100 bulbs may not be relevant. But the fact is, compared to N naught, N1 is a small number, and therefore we choose to ignore that number. And it's also possible that there could be a higher probability of the bulbs failing also. So we, although logically might think it should have been N naught minus N1 into P2, we ignore N1 because it's relatively smaller in comparison to N naught. So likewise, we calculate the number of bulbs that fail at the end of the third week, fourth week, and fifth week. So you find 100 bulbs at the end of the first week, another 160 bulbs in the second week, 281 bulbs in the third week. In the fourth week, we have 377 bulbs failing, and in the fifth week, we have 350 bulbs failing. Now remember, this 377 bulbs failing also include the bulbs that had been replaced in the immediate preceding weeks. So it's not just the original 1000 bulbs, it could also include the bulbs that have been replaced in the immediate preceding weeks. So here we have this data which shows how many bulbs fail in each of the weeks. First week 100, second week 160, third week 281, fourth week 377, and fifth week 350. Now remember, These are not cumulative number of bulbs that fail. These are the number of bulbs that fail in each of these weeks. Now we'll have to prepare a table like this. The week, number of bulbs replaced, then the cumulative number of bulbs replaced, then cost of the number of bulbs that is replaced individually. This is the individual cost, and this is the total cost, which includes the initial cost plus the cost of individual replacement here, and then the average cost column. Average cost is equal to total cost divided by the week. Now this is what we had just computed from our N1, N2, N3 and so on. So at the end of the first week 100 bulbs, in the second week 160, the third week 281 and so on. So this is cumulative. 100 plus 160, 260, 260 plus 281, 541, 541 plus 377, 918, 918 plus 351, 268. Now if I were to buy them at the cost of 2 rupees per bulb, it is 200 rupees for me, 520. So it's 100 into 2, 200, 260 into 2, 520, 918 into 2, which is 1836. Now this is the total cost, which is 1000 bulbs bought at 50 paise per bulb. That's 500 rupees. So that 500 plus this 200 is 700. 500 plus 520 is 1020. 500 plus 1082, 1582. 500 plus 1836, 2336. 500 plus 2536, 3036. Now the average cost is the total cost column divided by the week. So this should actually have been 700. This is not 100. So this is 700. 700 divided by 1, 700. 1020 divided by 2, 510. 1582 divided by 3, 527. 2336 divided by 4, which is 584. 3036 divided by 5, that is 607. So we keep looking at this last column like we discussed in the replacement of capital items. We keep looking at the cost decreasing, and whenever it begins to increase, that's the point of change. So here you find at the end of the second week, or till the end of the second week, the costs are decreasing, and from the third week onwards it's beginning to increase. So it's wise for us to replace the bulbs in bulk at the end of the second week, and that will still cost us 510 rupees, which is lower than 598 rupees per week, which would be the cost of replacing the bulbs as and when they fail. So this would be about 510 rupees if we go in for group replacement, as against the 598 rupees per week if we go for individual replacement. So what is recommended here is we replace the bulbs in bulk once in every 2 weeks. So that brings us to the end of the replacement of group items. So happy solving.